Good day everyone, I am Dean Mars S. Awid and today we will talk about my insights on map projection, Earth coordinate system, and general information on nautical chart. So first we will talk about the Earth's coordinate system. So the Earth in which we live in is roughly a spherical in shape. So it means that it is not a perfect shape. So it is called oblique spheroid. But for navigational purposes, they considered it as a perfect sphere. So our planet Earth rotates about a fixed diameter called the Earth's axis. And the extremities of the Earth's axis are known as the Earth's poles. So there are two great circles on the Earth. So the first is the meridian and the equator. So the meridian is a great circle whose planes passes through the north and south poles of the Earth. Would describe into two semi-great circles which are diametrically opposite to each other. These semi-great circles are called meridians. So the next is the equator. An equator is a great circle whose plane is perpendicular to the plane of all meridians is called the equator. The equator divides the Earth into two hemispheres. The hemisphere which covers the area of the North Pole is called the Northern Hemisphere. And the one that covers the area of the South Pole is called the Southern Hemisphere. So what are the angles on the Earth, or what are the angles on Earth's coordinate system? So we have two, the latitude and the longitude. So first is the latitude. So what is a latitude? Latitude is the angle that a parallel of latitude makes with a plane in the equator is called the latitude. Latitude is named either north or south. So there are 90 degrees northward from the equator, and there are also 90 degrees southward from the equator. So now we will talk about the difference of latitude. So the difference of latitude or DLAT are the between two places is an arc of the meridian contained between the parallel of latitude of the two places. So in finding the difference of latitude, so there are rules. So the first rule is latitude, as the name both south or both north, subtract the greater latitude to the lesser latitude. So the latitude different names, one north, one south, so you're going to add their latitudes. So the next is the longitude. So what is a longitude? Longitude is defined as the angular distance between the meridian of Greenwich and the meridian of the point, measured 0 to 180 degrees east or west from the prime meridian. So the maximum value of longitude in degrees is 180. The 180th meridian is diametrically opposite to the meridian of Greenwich. The Greenwich meridian and the 180th meridian divides the Earth into two hemispheres, the Eastern Hemisphere and the Northern Hemisphere. So finding the difference of longitude or the D-long. So finding the difference of longitude or the D-long are between two places in a smaller angle at the poles or the minor of the equator that is contained between the meridian of two places. So rules in finding the difference of D-long. If both longitudes have the same name, meaning they are on the same hemisphere, the D-long is the difference of both longitudes. If they are on opposite side, the one east and the other one is west, the D-long is equal to the sum of their longitude, provided that the sum is not greater than 180. In which case, the D-long is equal to 360 minus the sum of the longitude, and naming it to the contrary to the name what is found in a usual way. So next is the map projection. So there are three types of map projection. First is the Mercator projection. Second is the genomic map projection. Third is the polyconic projections. So first is the Mercator projection. Mercator projection, it is a cylindrical map projection. It is a standard map projection for navigation because it is unique in representing north as up and south as down everywhere while preserving local directions and shape. Next is the genomic projection. It is made by placing a plane surface tangent to the Earth's surface are then projected into this plane. The point of tangency may be at any location. A special case of genomic chart occurs when the geographic pole is selected as point of tangency. In this case, all meridians will appear as straight lines and parallels are as concentric circles. The result is a chart that is used in the polar regions where ordinarily Mercator charts cannot be used. So the last is the polyconic projection. Polyconic projections are developed into a series of cones tangent to the Earth. It is termed polyconic because it is used separate cones for each parallel of latitude. The vertex of the cone is at the point where a tangent to the Earth at the specified latitude intersects the Earth's axis as extended. So the next are the general information on nautical charts. So there are four nautical charts. So the first one is the ocean chart or sailing charts. So it is the scale of this chart is 1:600,000. It is used for open ocean navigation. The next is the general chart. The scale of this chart is to 1 inch is to 150,000 inch. To 1 inch is to 600,000 inch. It is used for voyage planning. The next is the coastal charts. It is used for coastal navigation, outlaying reefs and shoals. So the scale of this chart is 1:50,000 or 1:150,000. So the next is the plan chart or the harbor chart. So it is used for inshore navigation and navigating large inland waterways. So the scale of this chart is 1:2,400, and that's all. Thank you.